Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, I'm very glad to meet you again. I hope you're doing well. My name is Callixte. I teach mathematics, and today I'm going to be together with the senior 2 students. And as you can see, we are going to learn a new lesson. Lesson number 6, that talks about compound inequalities. But as you can see, we are still under unit number 3, simultaneous linear equations and inequalities. I hope you remember the introduction we did last time on inequalities. Now, when we talk about compound inequalities, I think every one of you is getting something new from there. We have the word compound, and of course, we have the other word, inequalities. When things are not equal, of course, they are not equal. And there are some signs we learned last time that explains to us when can I know that this quantity is greater than the other one, or this quantity is less than the other one. Now, I want to take you through the definition of what is compound inequalities. Because before we go into mathematics and we calculate or we solve the inequalities of regarding x, we need first of all to understand what is compound inequalities. On my PowerPoint presentation, as we have it here, it tells us that a compound inequality is a sentence with the 2 inequality statements joined either by the word or by the word and. Here, we need to understand that there are 2 words we use when we are talking about the inequality statements. We have the words or, and we have the word and. These 2 words are very important. I want you to keep them in your minds because they will help us to be able to solve the inequalities, especially compound inequalities. And as you remember, before we go far, I will give you one activity regarding the simple inequalities so that you can remember what we discussed the last time. When you continue regarding this definition, these 2 words, or and, indicates that both statements of the compound sentence are true at the same time. I want you to understand this. When you have the word or maybe the word and, those 2 words they are there to explain to you if the 2 statements are true at the same time. Now, it is the overlap of intersection of the solution sets for the individual statements. When you have this word or and, let me start with the and. If I'm given 2 inequalities, and between those 2 inequalities, or between those 2 statements, if I have there the word and, this explains to me that at the end of the day, I will have a solution that shows the intersection. You remember in the senior 1, we symbolize this intersection with this sign. Whenever I have 2 inequalities, and between those 2 statements of that inequality, if there is the word and in between, between them, it means I will have the solution that shows me the intersection at the end. We will see this in the example. When we go to the word or, in case you have 2 statements, and between those 2 statements we have the word or, this word or indicates that as long as either statement is true, the entire compound, here I want you to understand, the entire compound, underline this word, entire compound sentence is true. It is the combination or union of the solution sets for the individual statements. In other words, if I have this word or, It means the solutions that we get at the end will be symbolized by this sign for union. Simply, if I have and, put this in your mind, you have intersection. If I have the word or, you have union. Do you see this? Now, a compound inequality that uses the word and is known as a conjunction. Now get this. Whenever I have two statements and the equality that uses that word and, we will call it a conjunction. It means if I have this and, I will have the word also conjunction. The word conjunction. And whenever I have the word or, this one, we will see it later. When I have that word or, we call it disjunction. Disjunction. And I want you to understand this. When I have the word and, it means there is disjunction. I will call that inequality disjunction. And if I have the word or between the two statements of my inequality, I will call that inequality disjunction. And I have made research about this to make you understand the meaning of the word conjunction. You put this, you see this? Conjunction, means with another. But when I have this word disjunction, this means one or the other. I hope you've now understood this. But I want you to copy them down because these are very important in your life. You should really understand this and keep remembering them. Now, before I take you through the examples regarding the compound inequalities, there is one simple activity that I want you to work on. If you have worked on this activity before, solve for x. I want to give you one activity and you work on it before we go to the exercises. If you have 3x plus 2 less than 14, I want you to work on that. It's not of what we are supposed to work here. This is the activity that I have for you. You solve for x. Now work on this. You will give me the answer for x. I think it's all about what we learned last time, because last time we've been discussing about the inequalities. We saw the introduction on inequalities. And I think it will be very easy for you. You try it down, just on a paper or in your exercise notebook, and then within like few seconds, we're going to look at the solution of this together. I always love to see students trying, because in mathematics, when you don't do the exercises, I don't think if you can for sure understand something. You need to do many different exercises. I encourage you to do many different exercises every time. I hope you finished. Let's do it together. When you have 3x plus 2 less than 14, we've learned these signs. We are going to solve for x. Now we have 3x. You take this one, it goes over there. When it goes over there, it changes the sign. You now have 14. Here it has been plus. Then now it's negative 2. And you remain with the 3x less than 12. But you are not yet done because you were told to solve for x. It means at the end of the day, you need to see the value of x. Now you have 3x. You divide by 3 on both sides. It's just like as we do when we are solving the equations. They are going, here we get x less than 4. You see? Now we have x. It's all the values. X stands for any value, any number. All numbers which are less than 4, that's the solution we have. But there is also something that I want you to do. Do you remember how to present this solution on a graph? I think you do. But we can do it together so that you can really remember how to present a solution on a graph. When you do this, let me do it from here. There is no problem. Allow me to use this space. Here we have 0, and remember to put this negative infinity, positive infinity, and show that your line is going on both sides. Here we have -1, -2, -3. We have 1, we have 2, we have 3, we have 4. Do you see this? And there is something they told us. The numbers which are less than 4. What does it mean? We have now 4 here. All these numbers, they are less than 4. And do you remember why I'm opening this circle? It's just because 4 is not in the set of solution. That's why I have to open this small circle. So here we have the solution. It means all the values which are on this side up to negative infinite, they are in the set of solution. Students, I hope you remember this. Now, we are going to do some exercises, examples on compound inequality. Whenever you have this, where you get the answer like this, it's all about simple inequalities, because we have simple inequalities and you have compound inequalities. You've seen how it is very easy for you to get the answer, okay? Now, we are now going to do examples about the compound inequalities. Let me clean these parts. And also this one, I hope you've finished. Now, as you can see, we have example number 1. I'm going to read it for you, and then we will do it together. We have 3x plus 4 less than 14, and remember this word, and 2x minus 5 greater than 11. So we are going to solve for x, as you can see, solve for x. We have examples. Example number 1, solve for x. The question is this one. I can even remove this so that we use a piece of chalk, not marker. It would be very good if we use this. We have 3x plus 4, 14, and 2x minus what? It was minus 5 was greater than 11. We are going to solve this together. Solution. So before we solve it together, I want you to know how to write it very well so that you may not get confused. You have to write it like this. 3x plus 4 less than 14, and I want this word to appear there, 2x minus 5 greater than 11. It is very easy. You just do it as we did the first activity. How would we do this? Can I give you a few seconds and you try it out? I think it will be very nice. Try it out. Just one part to the other one. Now, if we look for the solution, whoops, we've written it already. We have now 3x. We are going to first work on this one. 14, 4 goes on the other side. It becomes 4. Okay? And we have also, let me put 2 here. This is 2. So that it will be 3x. And this is 12. And you have x. This is a 12 over 3. And you have x less than 4. Do you see the first answer? We changed this for it to be easy for you. Okay? To be easy for you. Now, let's work on the other side. We have 2x minus 5. Here we have 11. And 11 plus 5, because this one goes on the other side. We remain with 2x, okay? Greater than, what do we have here? 16. And we have x 16 over 2, we have x greater than 8. Do you see this? Now, when we have this, you can present it on a graph. We have 0 here, negative infinity, and positive infinity. We are going to put on a graph. Here they told us that this is negative 1, negative 2, negative 3, negative 4, negative 5. We have 1, 2, 3, 4, 5, 6. Let me expand it. 7 and 8. On the first answer, we have now x less than 4. We have value x here. We have 4 here. And it's not in the set of solution. You see? Now, all the values which are less than this, we have this. These are the values we have. From 4, we have 4 here. It goes the other way. All the values which are here, they are less than 4. And we have also the value of x. Here we have 8. We have 8 here. What about this one? Let me make it bigger. Let me make it bigger so that you can, let's use this part. We have 0. This is 1, 2. I don't know if it will fit over there. I can remove this so that we have enough space. We can have enough space for us. Yes. Because I want you to understand this. We have positive infinity and negative infinity. So we have now 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm trying to graduate it without measuring. But of course, when you are doing so at home or maybe in class, you need to use a ruler so that you can have the same size. Here we have negative 1, negative 2, negative 3, and negative 4. We are going to put our solutions on that graph. We have x. We have 4 here. I better use the different colors. We have 4 here. We don't put it because it's not in the set of solution. And all x, they are less than 4. What are those values? They are these ones. All these values, they are less than 4. Let's use another color, like green color. Here we have x greater than 8. We have 8 here. Those values, they are here. They are greater than 8 because they are bigger than 8. You see? Now, for our compound inequalities, as you can see, I think you remember what we said on the word and. When I have and, I need to look for the intersection. When I look for the set of solution, do we have the numbers in common for these two inequalities? I want you to check well. Do we have them? For one, the solution is here. The solution is here. The other one, the solution is over here. We don't have the numbers in common for these two inequalities. That's why I can say the set of solutions for my two statements of inequality, it is an empty set because we don't have any number in common with these two ones. Now, let's do the next example. Example number 2. I prefer to write it with the big size. Example number 2, we solve for x. Solve for x. 2x plus 7 is less than 11, or negative 3x minus 2 is greater than 13. This is the next exercise that we are going to do together. Let me make a line here so that we can do our work very well. All right. Now, can you please try it just down? And you have to follow the same way we've been using on the first exercise. I can clean this one so that you may not get confused by having two things which are the same at the same time. You see? Can we solve it together? I hope you've tried it. Let's use this part. Solution. And you remember, I told you, we have and we have or. For the second example, we have now the word or. Let's do it together. Now you have 2x plus 7 less than 11, negative 11. Or we have negative 3x minus 2 greater than 13. We work on this. Here we have 2x. What do we have? We have now negative 11 minus 7 because it goes over there. We remain with 2x. Here it is negative 18. And we have x, negative 18 over 2. And we have x less than negative 9. Do we see this? We work on the second one, over here. We have negative 3x. This one goes there, and we remain with 13 plus 2. This is negative 3x greater than 15. And x will be 15 over negative 3. And we have x greater than negative 5. We see? Now we have the answers. We put them on a line and see. When we put them on a line and see, we have this. We have 0, 1, 2, 3, 4, 5, 6, 7, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. We put them on that graph. When you start with the first one, you have the x, which are less than negative 9. Where do we have negative 9? Oh, I have to continue. Negative 7, negative 8, negative 9. We continue. This is negative infinity. This is positive infinity. We have the x. They are less than this. Now we have this. It's going the other way. That's where we have a solution. Okay? And let's now solve the other side. We have changed the sign here. It was not supposed to be greater than it is less than, so that it may fit with the example we have. Now we have negative 3x minus 2 less than 13. We work on this. Here you have 3x. When this one goes on the other side, we have 13 plus 2. We have negative 3x less than 15. We now remain with x. It changes the sign because when we divide it, we will remain with 15 over 3, and the x will be greater than negative 5. This is the answer that we have at the end. Okay? Now, when we finish to get the answers on both sides, you remember we have the word or in between. We put them now on the graph. When we put on a graph, here we have the x is standing for any value that is less than negative 9. Where do we have negative 9? It's over here. We have negative 9 here. And you remember why I don't put the 9 inside, negative 9 inside. So from negative 9 going to negative infinity, that's where the solution E is. Okay? Now, from x, as we have it here, we have x stands for any value that is greater than negative 5. We have negative 5 here. When you have negative 5 here, all these values, they are going. All these are the values which are greater than negative 5. Here we have solution. You see? It means when you go back a little bit here, you remember we've said or, it means disjunction. We have one or the other. It means our statements, as we have them here, one solution can be this one or the other one. Let's do the other example that will explain to us, as you've seen, is like this one also is like for the other one as we have it here. I'm going to take you through the homework, and from the homework with time, we can do one more example. Look at the homework. We have solve for x. Negative 12 is less than or equal to 2x plus 6 and less than or equal to 8. Here we don't have any word that they told us. When we don't have and or, you have to know that you will deal with the word and. Whenever we don't have and or, you have to use the word and. It means you will solve for this part, and again you solve for this part, then you get the answer. And the second one is a 3x minus 2 greater than negative 8, or 2x plus 1 less than 9. Here it's okay because you have the word. And then here we have 4x minus 2, you see, greater than 10, or 3x plus 1 less than 22. Now, students, I think you've seen how it's very easy when you do work on this. But I'm going to give you the example that I'm sure it is all about the word and. Let me clean here. Because as you can see, the first example we did is all about all, because it is one solution or the other. I'm going to give you one example that can fit the condition of and. I think it would be very nice to give it to you. We have the word and. Let's solve for x. Solve for x. We have 3x plus 4, 14, and 2x minus 5, negative 11. I'm sure this one will fit. I thank you very much. When you do work on this one, it will show you at the end that you need to have a solution, negative 3, and the other one will be 4. On both sides, the one will come in this way, the other one comes in this way, and you will see now the solution will be between those two values. I thank you very much for your hard attention. Bye.